Hello friends, welcome to Susan and John MathTube. In this video, we're going to learn about cone. And type 1 cone means we're going to deal with the right circular cone. Okay, a few things before we start. So I think you can see a right circular cone and the minimum requirements so that we can find the equation are the vertex of the cone and its axis and the semi-vertical angle. I think you can see the axis passing through the vertex and capital A right through the base. And one more difference that you will notice between a cylinder and a cone is the generating line behaves slightly differently. In cylinder, we already discussed that there will be a guiding curve and the generating line will stay parallel to the axis. The generating line will stay parallel to the axis. But here, the generating line will touch the guiding curve, but it will pass through the vertex. So basically, you are collecting all the lines passing through a fixed point and touching the guiding curve. And I think you are able to see the cone. And another important thing, you see that a square in its 3D version becomes a cube and a rectangle in 3D version becomes a cuboid, and of course a circle becomes a sphere. So do you remember the 2D version corresponding to a cone? You might remember from class 10 or 11. Did you learn something called pair of lines? So remember, a pair of lines when it comes into 3D form becomes a cone. So most of the theorems which you learned in pair of lines will be seen analogous in cones. Now, one last time, the minimum requirements to write the equation of the right circular cone is the vertex, the coordinates of the vertex and the generating line. Basically we need the direction ratios of the generating line and the direction ratios of the axis and the semi-vertical angle. I think you can see that angle alpha. Okay, now the process is like very easy. What we do is we take the locus point on the generating line, and you know that the generating line together forms the cone. So I took the point to be P, X, Y, Z. And are you able to see that the generating line passes through P and V? So the direction ratios are X minus X1, Y minus Y1, Z minus Z1. Now the direction ratios of the axis will be given, or we will be able to find it somehow. And for theory's sake, I am going to assume it to be A, B, C. Now look at this. Always remember, equation means getting access to every point on a system. So now we are going to connect our generating line and the axis using the semi-vertical angle. So equation to the cone is given by, come on, tell me, what is the formula for angle between two lines in 3 dimension? Isn't it A1 A2 plus B1 B2 plus C1 C2 divided by root under the modulus? Okay, so we're going to get cos alpha is equal to, what is A1 A2? Okay, A into X minus X1 plus B into Y minus Y1 plus C into Z minus Z1 by the modulus of the first one, modulus of the second one. And simplify this, and that's it. That will be the equation of our cone. Okay, now let's try one question. Okay, so the question goes like this. Find the equation of a right circular cone with vertex 1, 2, 3 and axis x minus 1 by 2 is equal to y minus 2 by minus 3 is equal to z minus 3 by 6. Okay, so in examination, the first thing you have to do is you have to make a rough diagram, something which looks like this. Okay, so what is the vertex? Is the vertex given? Yeah, the vertex is given to be 1, 2, 3. So I'm going to mark 1, 2, 3. And then what you do is you take the locus point on the generating line, that will be x, y, z. And finally, what are the direction ratios of the axis? Okay, so look at the denominators. We get the direction ratios to be 2, minus 3, 6. And one more thing is given, the semi-vertical angle is 60 degrees. Okay, that's it. Let's start. So you have a rough picture. The vertex is given here, 1, 2, 3. The direction ratios of the axis, 2, minus 3, 6. And the locus point, x, y, z. And the semi-vertical angle, 60 degree. So you can start like this. Let P, x, y, z be the locus point or a point on the generating line. Now the direction ratios of VP is given by x minus 1, y minus 2, z minus 3. And direction ratios of axis 2, minus 3, 6. That's it. So what will be the equation of the cone? Just look at the semi-vertical angle. So we get cos 60 degree equal to, tell me what is the formula for angle between the two lines, generating line and the axis? A1, A2, that means I get 2 into x minus 1 plus B1, B2, that gives me minus 3 into y minus 2 plus 6 into z minus 3, the whole divided by root under x minus 1 the whole square plus y minus 2 the whole square plus z minus 3 the whole square and root under 4 plus 9 plus 36. I hope you understood where it came from. Okay, that's it. Simplify, you get the equation. And I'll leave that part for you. So you have a lot of steps coming up. That is 1 by 2 and then you square on both sides so that the square root will disappear, and that's it. You can try one more question. Okay, find the equation of a cone whose vertex is the origin and the semi-vertical angle is 30 degrees and axis the z axis. Okay, now look at this. So as I told you before, make a rough picture. So our vertex is origin and here goes our axis and the semi-vertical angle is 30 degree and it's given that the axis is z axis. Now look at this. When you see the z axis, you should always remember the vector k. I hope you remember from vectors, 1 unit movement in x direction is I, 1 unit movement in y direction is j. Similarly, 1 unit movement in the z direction will be k. And k corresponds to the vector 0, 0, 1 or 0i plus 0j plus 1 into k. So basically, the direction ratios are 0, 0, 1. So that's it. We have all the information that we need. So we start with, let P, X, Y, Z be a locus point. And then what are the direction ratios of PV? PV or VP, whatever you like. You can choose the direction. X minus 0, Y minus 0, Z minus 0. And what are the direction ratios of the axis? So that will be 0, 0, 1. That's it. So the angle will be cos 30 degree is equal to A1, A2 plus B1, B2 plus C1, C2 by root under 0 plus 0 plus 1. So that's it. This time simplification is very easy. So we get root 3 by 2 is equal to z divided by root under x square plus y square plus z square. Okay, simplify a little bit, that's the equation of the required cone. Okay, one more question. Find the equation of the right circular cone whose vertex is the origin and vertical angle and axis. Okay, so look at this. We go for our usual picture. And what is the vertex? It's given to be the origin. And then our axis is over here. Now look at this. Here they have given the vertical angle. So the semi-vertical angle will be half of that. That will be 45 degree. Look, it's given 90 degree as the vertical angle. So the semi-vertical angle will be 45 degree. Okay, and another thing, you should always write the equation in standard form. So what you do is a very simple thing. Divide throughout by minus 2. So you get x by minus 2, or 2 will be enough. Yeah, is equal to y by minus 1 is equal to z by 2. So we are dividing throughout by 2. You can divide by 2 or you can divide by minus 2. That's fine. So what are the direction ratios of the axis? 2, minus 1, 2. Now how do you start? Let the locus point be x, y, z. The equation is given by cos 45 is equal to, what are the direction ratios? So it will be 2 into x a1 a2 plus b1 b2 plus c1 c2 by root under x square plus y square plus z square and root under 4 plus 4 plus 1. Okay, that's it. You can simplify and make it look like an equation. I'll be back with another video. So till then, my friends, bye.